Okay, dear students, let us move on to engineering mechanics. Now let us do the friction part of the problems from engineering mechanics by Professor Timoshenko and D.H. Young. Problem set 2.7, solution to 2.100, 2.100. So let me read out the statement of the problem first. What must be the angle alpha between the plane faces of a steel wedge? Look at this red part. This is a steel wedge. This angle is alpha. This side, let me name it as B. Let me name it as A, and this point as C. So BC and AC are the two plane faces, and angle between them, the two plane faces, is alpha. Now, what you see in the figure, this green line is suppose a log of wood, and you are hammering this steel vase into the log of wood. When you hammer from this side, this steel vase, after hammering, will tend to move to this side. So, the two plane faces, that is AC and BC, which are in contact with the log of wood, will have a force of friction. And what will be the direction of the force of friction? Now, after hammering, when the steel wedge is trying to move up on this side, when this is trying to move up on side BC, the force of friction will be to this side along the surface of contact, and on the side AC, the force of friction, which is equal to mu times the normal reaction, here also mu times the normal reaction, where mu is the coefficient of friction, on the side AC it will be to this side. Now we have to find out that angle alpha. For splitting logs, if there is to be no danger of the wedge slipping out after each blow of the sledge. Now let us, I have drawn another diagram for you. So if you look at here, this is your steel wedge ABC. The angle ACB is alpha, this angle is alpha. So this line, which I have taken it as y-axis, will divide the angle ACB in two equal halves. Means this will be alpha by 2, this will also be alpha by 2. And on the side AC and side BC, there will be two reaction forces. I have shown it here for the side AC, and for the side BC I have shown it here. You can show it here, you can show it here, you can show it here. This reaction you can also show at any point, doesn't matter. Now, so these are the two reaction forces. AC, BC are the two faces of the steel wedge, therefore two normal reactions are N. And it is given angle ACB is alpha, so this is alpha by 2, this is alpha by 2. Now look, since this is normal to the surface AC, so this angle is 90. Since this normal reaction is normal to the surface BC, so this angle here is also 90. Now if you look at the triangle O, this triangle, or this triangle, if you look at this triangle, this is alpha by 2, this is 90, so this will be 90 minus alpha by 2. So the vertically opposite, this will be 90 minus alpha by 2. So this has to be alpha by 2, because here the y-axis makes 90 degree with x-axis, so this is alpha by 2. Similarly, if you look at this triangle, 90 alpha by 2, So this will be 90 minus alpha by 2. So the vertically opposite, this will be also 90 minus alpha by 2. So, and since this x-axis is perpendicular to y-axis, so this will be alpha by 2. Now, later on, to draw the free body diagram, I can translate this Rn to this point and show it here. And I can translate this Rn to this point and show it here. So that is what I have done in the free body diagram. So at the point O, this is Rn, normal reaction, Rn, alpha by 2, alpha by 2. And here, if you look at here, this force of friction on the side BC, if you extend this line, making angle alpha by 2 with vertical, this is also making alpha by 2 with the vertical. So I have shown it here in the free body diagram. The force of friction, which is nothing but mu times normal reaction. That this is what you have studied in your school days. Force of friction is mu times the normal reaction. Now here, if you split Rn, this Rn and this Rn to a horizontal component, this will be your Rn cos alpha by 2, and this will be your Rn cos alpha by 2. They are equal and opposite, they will cancel. So along y-axis, if you drop a perpendicular here, this will be your Rn sin alpha by 2 for this Rn. And if you drop a perpendicular here, this will also be Rn sin alpha by 2. So we have 2 Rn sin alpha by 2 along positive y-axis. Similarly, for equilibrium, we need an equal amount of force along negative y-axis. So the component of this force of friction along negative y-axis will be from here to here. That will be F cos alpha by 2, and the component of this F will be also along negative y-axis will be F times cos alpha by 2. So on positive y-axis we have two forces, Rn sin alpha by 2, 2 Rn sin alpha by 2, and along negative y-axis we have two forces. One is F cos alpha by 2 for this one, another is F cos alpha by 2 for this one. And you might ask, then what happens to F of sin alpha by 2 for this one and F of sin alpha by 2 for this one? They will also cancel. F of sin alpha by 2 for this one will be to this side. F of sin alpha by 2 for this one will be to this side. So they will cancel. So taking sigma y is equal to 0. So we have now, I hope the diagram is clear to you, and the direction of the force of friction is also clear. Then we have 2 times Rn sin alpha by 2 is 2 times F cos alpha by 2. Using sigma y is equal to 0, sum of the forces along y-axis. So 2 cancels. So Rn sin alpha by 2 is F times cos alpha by 2. Now bring cos alpha by 2 to the left hand side, take Rn to the right hand side. So sin alpha by 2 over cos alpha by 2 becomes tan alpha by 2. Force of friction by normal reaction, as you know, this is nothing but the coefficient of friction. And if you consider theta as the angle of friction, we know tangent of the angle of friction is the coefficient of friction that we studied in your school days. I took theta, it is in the book, it has taken as a phi. So where theta is the angle of friction. So taking tan inverse function, so alpha by 2 is theta, so alpha is 2 times theta. Means the angle between the two plane faces, AC and BC, alpha should be less than equal to 2 times the angle of friction. So I hope it is clear to you. Some of you had requested to upload videos from the friction part. So I have started doing. Maybe next week I'll be able to finish all the problems from the friction part of engineering mechanics. So keep watching, keep enjoying, and if you still like, and give your feedback. And if you have not subscribed, feel free to subscribe and pass on to your friends at different engineering colleges pursuing their civil engineering, mechanical engineering, or computer science, whatever. Thank you. All the best.